And now we're looking at graphing numeric response question number 3. This one's on page 6 of the booklet that I gave to you guys in class on Friday. So we got an experiment here where we're crashing one cart into another cart. Cart number 1 is moving before the collision. Cart number 2 is at rest. There's a piece of clay in the middle here, so the carts stick together upon the collision, then they head off as one object. We've got a graph here of the speed of carts 1 and 2, the combined velocity after the collision versus the speed of cart 1 before the collision. Cart number 2 isn't moving before the collision, right? Cart number 1 before the collision, both carts combined after the collision. Now here's another one where we don't have a trend line given to us. If we did, we would pick 2 points on the trend line and do our slope thing. But because we don't, we're going to have to identify all of the ordered pairs of each of these data points. Now, watch your intervals on your axes. 1.2, 1.4, 1.6, 1.8. We're going up by 0.2 on the x-axis. So my x-coordinate is 1.4. My y-axis, we're going up by 0.1, 0.2, 0.3, 0.4. We're going up by 0.1 on the y-axis, 0.2 on the x-axis, and 0.1 on the y-axis. All right, so 1.4 and 0.4 is my first ordered pair. Then the second one, I have 2.4 and 0.9. The third one, I have 3.2, 1.15. Fourth one, 4.3, 1.85. Fifth one, 5.4 and 2.3. Sixth one, 6 and 2.4. And the seventh one, 6.4 and 3. Make sure you can get all of those ordered pairs. Punch them into your calculator, stat edit 1, stat calc 4, and that will spit out the slope for you. It's going to be 0.48568, and the y-intercept is 0.3, but that's pretty small. We're not quite going through the origin there, but pretty close. So I'm not going to pay much attention to that y-intercept. Now, we do need an equation from the graph and from class, as always. And the good news, as always, the equation from the graph will be y equals mx plus b. So we're going to say VF, the combined mass, the combined velocity of both cars after the collision. M stands for the slope. X-axis is the speed of cart 1 before the collision. And the equation from class that relates all this together, PI equals PF. M1 V1I plus 0, because cart number 2 is at rest, M total times VF. We're going to solve for VF because that's what we solved for over here. So let's say VF is equal to M1. Let's take the M total over by dividing. VF is equal to M1 over MT times V1I. Now, let's cross off VF because it's in both. Let's cross off VI because it's in both. We're left with the slope is equal to M1 over mass total. Don't even know what the question is yet. And we've identified what the slope represents here, mass 1 over mass total. Now let's look at the question. It says, the collision of the two carts is classified as elastic or inelastic. Well, these two cars stuck together, so we know that when two things stick together, kinetic energy must be lost. So it must be an inelastic collision. D would be our answer for that one. And 4 says, based on a point on the line of best fit, cart 1 has a speed of 6 centimeters per second before the collision. Then the combined speed after the collision would be what? Let's do our equation from the graph. VF is equal to the slope times VI. We know the slope is 0.48568. If our x coordinate here is 6 centimeters per second, then our y-coordinate, or our final velocity of both cars combined, would be 2.9 centimeters per second. So AB would be 2.9 centimeters per second. And then finally, based on the slope of the line, the combined masses would be, well, remember we said that the slope of this graph was m1 over mass total. We're looking for the combined masses. So we're going to say m1 over the slope. That's going to be 1.54 kilograms divided by the slope here, 0.48568, gives us a mass of 3.2 kilograms. So EF, the value of the combined mass here in kilograms, would be 3.2 kilograms. 2932, bubble it in as 2932.